Hi guys, we want to determine the transfer function of this circuit. And so guys, as you can see, we want to find V2S all over V1S. Guys, I have drawn the diagram right here. And so guys, what we are going to do, we are going to use this loop and also this loop. So in using the loop 1, guys, we are going to loop 1 is going to give us V1 equals to VR plus VC. That is for loop 1. The PD across this loop is VR plus VC, and which is equal to V1. Then for this loop, guys, we are going to have V2 is equals to actually VC, like that. After we have gotten that, guys, we need to remember this equation. Let me just write it here, whereby we say I, which is current, is equals to dq all over dt. That is, the rate of flow of change is the same as the current. So we take that in mind. So guys, we continue. We shall have now V1 plus I is equals to, the VR is supposed to be Ri plus the VC, guys, is supposed to be 1 over C integral of I dt, like that. And so is the same with the V2. So this is 1 over C integral I dt, like that. So guys, we continue. From there, guys, we are going to do like this. We are going to equate this VC into V2. That is, we are going to have V1. Let me write V1 is equals to VR plus, now we write V2, just as we have here. V2 is equals to VC. Then guys, we come to this equation here. Guys, we know that Ri is the same as writing. We shall write this Ri is equals to V1 equals to R. The I we have is dq all over dt, now plus the V2, like that. And then guys, we continue, so that guys, we can get dq over dt in terms of V2. We shall come here, guys, and differentiate both sides. So if we differentiate this side, we shall have dv2 all over dt is equals to 1 over c. Guys, if we integrate an integral, we will have now d all over, that is, if we differentiate an integral, we shall have 1 over c dt integrate I dt. Guys, this is now going to be equal to, remember that when you differentiate, you reverse, meaning that it will now be as it were before we had put the integral. And so we shall have I all over c. This is our solution, guys. And therefore, guys, even writing here, we shall have now dv2, then we have the c, we can bring it there, all over dt. This is now equal to, guys, I, like that. So with this I, guys, now we can come and now, as you can see, guys, here I is dq all over dt. So this is the same as dq all over dt. And this is what now, guys, we are going to replace here with this function that has v. And so we are going to have v1 is equals to r. Instead of writing dq dt, we write c dv2 all over dt plus v2, like that. Guys, we write that in Laplace transform. When we write in Laplace transform, can write here Laplace transform for that. Guys, we are going to have v1s equals to rc. Here we shall have s v2s plus v2s. From there, guys, we can factor out the v2. Shall have v2s, and then here we shall have rcs plus 1. This is equals to now v1s. And so therefore, guys, our transfer function is going to be v2s all over v1s. This one is given as 1 all over rcs plus 1. So guys, this is our transfer function. So thank you guys for listening to me. Bye.